Okay, capacitance can be obtained by determining the following. So, we'll have first the electric field strength E from Gauss law. So, this Gauss law is simply stating that the total electric flux leaving a closed surface equals the total charge that is within the volume that is enclosed by the surface. So, yung normal component of the electric flux density, i-integrate over a closed surface. And that is equal to the charge that is enclosed. Okay, so your D here is the normal component of the electric flux density, and then your E here is the electric field strength, no? Normal component of the electric field strength. DS is the differential surface area. Okay, so we have to remember that from Gauss law, electric charge is a source of electric field. Okay, so there's a charge, so there's electric field. Okay, and that electric field lines are originating from positive charges and then terminating at negative charges. Okay, and then after having the electric field, na obtain na natin electric field, we'll make use of that to get the voltage between the conductors. And then eventually, when we had the voltage, we'll get the capacitance through this equation. Charge over the voltage. Okay, so that is how your capacitance will be developing, no? From getting the electric field and then the voltage and then capacitance. If you can also recall, no, diba, we had these 4 parameters also that we need to determine sa inductance, diba? Starting off with the magnetic field, intensity, and then density, and then flux linkages, and eventually yung inductance. So, the same thing here kay capacitance, no? Starting off with the field strength, and then the voltage, and then eventually capacitance. Okay? Well, of course, we have our assumptions also. Number 1, we are assuming that the conductor is actually uniformly charged and it's a solid cylindrical conductor, no? So aside from that, we're neglecting the end effect of that conductor. So parang the end effect, that's so hindi na natin kita eh. So it's sufficiently long, the end effect hindi na natin kita, so negligible na lang siya. And then this conductor is a perfect conductor. That is, your resistivity of that conductor is definitely 0. Okay? So talagang perfect conductor siya. And in that case, the internal electric field, okay, here is 0. Unlike a inductance, right? If you can recall, no, we started with getting the internal flux, right? And then susunod external flux. Okay? And then eventually hanggang sa mag-lead up to the inductance, no? So, but in this case, for capacitance of transmission lines, because we are assuming that it is a perfect conductor, so the internal electric field is now 0. So, ang focus natin ngayon will be the electric field that is outside, okay, the conductor. Okay? Yan. I hope that's clear.